boys and girls, moms and dads, we have a guest who is currently patiently awaiting our attention. Tonight's guest is John, W6NBC. He's going to talk about antennas and where to stash them so that the neighbor lady doesn't call the cops and have you arrested and thrown in jail. Go ahead, John, give her.
Okay, sharing the screen and hidden attic antennas. Get it up full screen there. Get rid of my thumbnails. Move that up out of the way. And go to the slideshow. There it is. From the current slide. All right, you should all be seeing the title slide, Hidden Attic Antennas. Is that good? Excellent.
It's a little.
All right. Lots of us these days, we may not live in houses quite this exotic, but although we may live in houses more exotic than this, who knows? But the worst thing about it is that many of us may have neighbors. And of course, the deadly homeowners association, the deadly association, those wonderful people who like to get together and hear themselves talk once a month and say nothing. But they certainly like to come around and see that you're not doing anything that they don't like, particularly putting up antennas. Now, I've done a lot of antennas designed to thwart homeowners associations. This was one of them. These were little copper pipe antennas. Hams love to make things out of copper pipe and PVC, and of course these antennas were made out of both those two items, a 2 meter in my right hand and a 6 meter in my left hand, slot cube antenna, which were very popular, and both won me cover plaque awards in QSD. And they work very well in attics, although they're quite small, and they work outside pretty well, so make good attic antennas too. But the best reader email I ever got, I just going to show you this one for fun, was from a reader who made one of these antennas and put it up in his attic. And he said that building the two antennas, these two antennas that I just showed you, the cost of materials was $79.63, mostly for the copper, I guess. But then having your 16-year-old grandson put them up in the attic led him to these expenses. I guess the grandson wasn't that aware of how you walk around up in an attic. $2,600 with foot deductible. Well, I think as most of you know, many of you may live in a house, something like that, realize that to put an HF antenna up in your attic is quite a chore, just simply because of the size of the thing. An 80-meter antenna, a half-wave dipole, is 128 feet long. And so I've made it red there, seeing that it's not exactly an easy thing to do. A 40-meter antenna begins to get something that you might get in, got a fair-sized home, even my mobile home, which is 57 feet long, almost long enough for a 40-meter. Of course, I can't get in the attic of it anyway, but a 20-meter antenna, yeah, you can maybe get a 20-meter antenna up in the attic of a typical house, and certainly a 10-meter. So the color of the antenna sort of shows how likely you are to get it up there in the attic. But the solution, if you want to get a lower band antenna up there, is to add to this piece of wire that you put up in the antenna a high inductance loading coil. Now, we use loading coils to make small antennas work on our car. You know, we could make 80-meter or even 160-meter antennas work on our car by using loading coils. Well, we can do the same thing up in an attic. In fact, we've got more room up in the attic to use even bigger loading coils up in the attic. And so the use of a loading coil on an HF antenna is not an unknown thing. Like I say, we might use a loading coil even in a dipole out in the backyard to make a 160 or an 80 meter dipole shorter, so it'll fit in our backyard. Or if we want to run mobile 160 or 80 or 40 meters, we obviously are going to use a loading coil. There's an outback or antenna with a loading coil on it. So loading coils are common in HF antennas. And that's of course what the subject of this talk is about a particular kind of a loading coil that I think is particularly useful for doing attic antennas. Now, HF loading coils for use up in attics, and here's one of them that I got off of a website. If you want to do a loading coil efficiently, you want to do a loading coil that's big. So big is beautiful when it comes to loading coils. This I thought was a particularly good, this is a homebrew loading coil, and I thought whoever built this loading coil did a very good job at designing the mechanics of this loading coil. A couple of nice piece of, looks like fiberglass tubing there in the middle and some aluminum tubes and some aluminum brackets, and then some nice big husky aluminum or copper tubing to wind the loading coil out. That's a pretty efficient loading coil. And that's what we want, of course, because oftentimes the biggest loss in an antenna comes in the loading coil. That's certainly true of mobile antennas on cars. You know, your Hustler whip on your car, most of the loss happens in the loading coil. Just put your hand on the loading coil after you've had a long QSO. If you don't believe it, the loading coil is warm, because that's where the loss is occurring. So if you're going to build an attic antenna, you want the coil as big and as husky as possible. And that's, of course, what I'm aiming at in this talk, is showing you how to maximize the efficiency of an attic loading coil. However, if you can run down to your local builder's store, I have a Lowe's and a Home Depot near me. I can go down to the Lowe's near me and price a roll of 1/2-inch copper tubing. Haha, $91. And it just went up to $104. Here's just some prices I got just the other day. And if you're going to build yourself an efficient loading coil, you're going to spend some bucks on the copper tubing to build it out of. But if you want an efficient loading coil, this is what you're faced with. Well, not necessarily. Not necessarily. It's a good way to do it, but it isn't the only way to do it, as I'm going to show you. Here is a much less expensive way to do it and gives you just as good efficiency as building it out of that $100 roll of copper tubing. It's a cardboard tube and some copper tape, which is much less expensive. In fact, more recently, I've gone to aluminum tape, or as the Brits call it, aluminium tape. It works just as well as the copper tape, by the way. When I was first doing this loading coil, I was doing most things in copper. More recently, I've gone to aluminum, which works just as well. Anyway, so this is the kind of a loading coil I'm going to show you how to build. And it's easy to do. And the way this particular loading coil is used is this way. You hang the loading coil up in your attic with some pieces of rope and hang it from the top, or you can even lay it on the rafters if you want to, on the ceiling joists if you want. But it works best if you hang it from the peak of the roof, if you've got a peaked roof, and hang it free as possible from anything. And it's 4 feet long, the loading coil. And then the antenna is made up of the loading coil and then 2 additional pieces of wire, or I use tubing, usually copper or aluminum tubing, off the end to make up the full dipole. So it's a big loading coil and 2 extra pieces of tubing or wire off the end to make up the full loaded half-wave dipole up in your attic. This particular one here that you see is up in the attic of a good buddy of mine in my local club, WB2 FXO, Greg, who loaned me his attic. I don't have a big attic like this, so I had to do this one up in his attic so I could take a picture of it for you, show you in this presentation. But it works very easily to put one of these up there. And this is a 40-meter one that you're looking at right now. They're built on cardboard tubes. The best way to get these cardboard tubes is you go down to your local builder's supply. I have a Home Depot, and there are Home Depots all over the country. And these are cardboard tubes. They usually come in sizes about 12 inches in diameter. Actually, they come in nesting sizes. They make them in 12 inches and in a nest down to 12, 10, 11, 10, 9, so forth. You want to buy the biggest you can get. They come to up to 12 inches in diameter. So take a tape measure with you so you can get the bigger ones. They're all called 12 inches, but frankly, they're come in a stack. But take a ruler with you so you can get a 12-incher. They're 12 inches in diameter, 48 inches long, and they're cardboard, and they sell for about $16. What are they for? Well, they're made for contractors to use to pour concrete into to make concrete posts for use for decorative purposes. So relatively inexpensive, but they make a great loading coil. Another, perhaps even cheaper source, go down to your local carpet dealer. And sometimes carpet dealers have big cardboard tubes that they'll give to you for nothing, come in diameters up to 10 and 12 inches. So these cardboard tubes are relatively available. And up in an attic, cardboard is fine. You can even use them outside if you give them a good coating of paint. But up in an attic, you don't need to do anything to them. Just use them as cardboard because it's dry up in the attic. And what do? You put foil tape, self-adhesive foil tape on it. Originally, I was using both copper and aluminum foil tape, as you can see it. You can get it readily from Amazon.com on the internet, and it comes in all sorts of widths and all sorts of thicknesses. You can get it from 1/4 inch wide up to 4 inches wide, typically, on Amazon, and I've even seen it wider than that. The copper tape is used for a variety of reasons, usually for crafters who like to make stained glass windows. And the aluminum is often used for making heating ducts, for taping up heating ducts. You can buy that down at your builder's supply. Many people will say, well, copper is better, isn't it? I'm sorry, let's back up here. Sorry, oops, wrong way. Yeah, back here. Many people will say, well, isn't the copper better? Well, I thought at first copper was better because it's more conductive than aluminum. Well, yes, copper is more conductive than aluminum, but the skin depth in copper is only half as deep as it is in aluminum. So aluminum tape and copper tape are absolutely equal in building foil tape antennas because all of the current runs on the surface. There's no current running on the inside of the conductor. So a piece of 1 inch wide aluminum foil tape is just as good as a piece of 3/8 inch aluminum or copper tubing. So if you think a piece of aluminum tubing 3/8 inch in diameter or copper tubing 3/8 inch in diameter will handle current, so will a piece of 1 inch wide, 1.5 mil thick copper or aluminum self-adhesive tape will be. So don't fear using tape to build antennas out of. It's a great building material.
I got a question.
And yes,
On that tape, if you use wider tape, will it increase the bandwidth?
yes, it will.
Okay.
Yeah, sure. Anyway, the tricky part though is putting the tape on the tubing. If any of you have ever tried to put down self-adhesive shelf paper lining or put some self-adhesive materials onto a surface, no, it's tricky stuff to put on. It wrinkles and crinkles pretty easily. So I had a little trouble figuring out how to get that tape onto that tubing nice and evenly and nice and properly spaced. Well, here's how you do it. It's really quite simple. You just get yourself some moderately heavy paper, cardstock, typical paper cardstock, or some thin plastic which you can cut out of notebook covers on a paper cutter. And you cut yourself some strips of thin plastic or just thin cardstock, twice the thickness you want to make the turns on the tubing. And then you tape it together until you get a nice long strip. And then you just wind that paper tape onto the cardboard tube, and you butt it together like you see me doing right here. And then you wind it on, and then you use the edge of the paper tape to mark a helix with a Sharpie pen onto the cardboard tube to give you a marking guide on the cardboard tube to where to apply the metal tape. You could, if you use PVC pipe, for example, which you can also use to put the tape onto, you can make metal foil tape on PVC pipe. I've done it on small diameters and bigger diameters, 4-inch pipe and so forth. In fact, I had an article in QSD some time ago of a 2-meter helix done with foil tape on a piece of 2-inch PVC pipe. Did it the same way. Made a mark on it with a piece of a paper guide strip like this. Very easy to make a little mark on. Once you got that mark on the whatever you're going to wind the metal foil tape on, you just slowly peel off a little bit of the back, stick down a little bit of it, and slowly unpeel it as you just lay a little bit of it at a time right along the mark, pulling the backing off slowly as you push it down onto the tube. And you can get it on very smoothly and very accurately and make no wrinkles in the foil tape. If you just pull the backing off and try to stick it on en masse, you're going to make a mess. So, there are many possible uses for this coil. And here is the coil. Here is the coil turned into a 40-meter antenna. And you can make an 80-meter one if you want to by using more than one coil, for example. Or you can make it into a 20-meter antenna by making it shorter or using wider turns and more bandwidth if you want. So you can adapt this. You can adapt this idea very easily. I'm just showing you one example of how you can use it in a 40-meter one. And by the way, this antenna, if you will notice, is only 2 times 10.5 feet, which is 21 feet, and 4 feet, which is 25 feet long. That's only 1/3 the length of a 40-meter dipole, which is almost as efficient as a full-size 40-meter dipole. Because of that copper tape, that is a very efficient antenna. Now, it's narrower in bandwidth. Yes, it is. But it's just as efficient as a full-size 40-meter antenna because of the heavy copper tape and it's an efficient antenna. Big loading coil. Very good antenna. Very efficient. Works very well. Now, how is it coupled to? You can see the coupling here. I coupled to this antenna, like I coupled to a lot of antennas, with a separate coupling loop. You can see it here. It's a little, I made it octagonal simply because I have a tubing bender to do it with. I took a piece of 1/2-inch tubing, 1/2-inch metal tubing, aluminum tubing. You can use copper tubing if you want. And a tubing bender. I have a tubing bender, or if you make soft copper tubing, you can bend it with your hands. And I bent myself a little 10-inch diameter loop that would go inside of the cardboard tube. Small enough that it would fit inside of the cardboard tube. It's a coupling loop to form a transformer, an RF transformer between the coil, the loading coil of the antenna and the one-turn loop. And it fits inside of the loop. And then it can be rotated inside of the loop for variable coupling, like a goniometer, if any of you know what a goniometer is, the old-fashioned coupling device. Forms a variable coupling RF transformer. And you can get a perfect one-to-one match with this antenna, with that little variable tuning loop, easily. It uses a one-to-one balun to isolate everything. Very easy antenna to build, very efficient antenna. The only shortcoming of being a small antenna, it's narrow in bandwidth, so you're going to need some tuning. We'll get to tuning here in a minute. But that's an efficient antenna. Can be adapted to any band you want to. You want to build it for a lower frequency, even 80 meters? Well, use narrower tape, or use 2 of these loading coils in series. You can do it quite easily. Or you can bend the wire a little bit if you want to. You can do a lot of things. I think if you've got some ingenuity, you can easily see how this can be adapted easily to the attic of most homes. Here's the coupling loop inside of the loading coil. This one is made out of half-inch rigid copper pipe, typical copper pipe that you can buy at the local store. You see the gap in it at the bottom where the coax hooks up to. It's just hooked shield to one side, center conductor to the other side, and a couple of spacers which go through, and they go through between 2 of the turns, and they allow the loop to be rotated so that you can vary the coupling. Frankly, once you get the coupling set, it'll pretty much stay there no matter where you have the antenna tuned to. If you change the tuning, the coupling will stay pretty much the same. And that's generally true for most antennas. Set the coupling first, set the SWR first. This is what sets the SWR. Once you set the SWR, you can change the tuning, and the SWR will stay pretty much the same. Now, why do we want such a husky loop? Well, it's explained by this diagram. Now, we're going to go into a little theory here, so if you want to fall asleep, as one of the persons said, is get out your cup of coffee so you can stay awake through this portion. But a little bit of theory for you. Why do we need to make the coil so husky? It's for this reason. All antennas, I don't care whether it's this one or your big 8-element beam or your vertical with 46 radials or whatever it is. All antennas have this circuit, equivalent circuit. 4 elements in all antennas. Transmitter at the bottom and a series loop of 4 elements. Inductive reactance, the coil, capacitive reactance, the capacitance in the antenna, and this is part of the antenna. It's not necessarily a coil, but it's part of the antenna. And 2 resistances. All antennas are made up not of these physical elements, but of these characteristics of some reactance, some inductive reactance, some capacitive reactance, some radiation resistance, and some conductor resistance. And the transmitter power that comes out of your transmitter is shared by all 4 of those. All 4 of them get the power from your transmitter. It flows through all 4 of them. Any one of them which uses any of the power is a source of loss in the antenna. Transmitter power needs a load to make radio waves. One of those elements is the load in which radio waves get made in an antenna. All of them pass the transmitter power. The tuning in an antenna, what you tune up when you tune the SWR in an antenna, does not use any of the power. The inductance, the capacitance of an antenna doesn't use power. Neither does the inductance or the capacitance of an antenna use any power. It's the other 2, it's these other resistances over on the right that use power in an antenna. These are the ones that consume the power: the conductor resistance and the radiation resistance. Now, the conductor resistance is just a simple resistance. How many ohms in the aluminum? The other resistance that's in the antenna is the radiation resistance. Now, that's the mysterious one, but it's the one that makes the radio waves. But it's mysterious, as Sherlock here says it. It may be a mystery to some of you. What's radiation resistance? Well, I like this little metaphor. It's like the whole of the universe is filled with jello. And all antennas are buried in that jello. And when you shake that antenna by putting radio energy into it, it shakes the whole universe. In other words, the whole universe loads all antennas. It's a real resistance that all antennas have in them, caused by the loading of the universe. It's called radiation resistance, and it's real resistance measured in ohms, and it's in all antennas. It's one of those two resistances. It's the one on the right, called radiation resistance. It's the one that makes radio waves. It's the good guy. That's the one we want to be high. We don't want the one on the left to be high, the conductor resistance. Whoops, where am I going? How did I get there? Sorry about that. I beg your pardon. I made it. Pardon me, I got sidetracked here. There we go. Back to where we belong. Okay, back to where we are. Radiation resistance. Now, this is what's important. Small antennas, and we're talking about small antennas when we're talking about attic antennas. How does the efficiency change in a small antenna as you make it smaller? As the conductor size of an antenna goes down, the conductor resistance, the bad stuff goes down. Yes, it does. But the radiation resistance goes down as the square of the size. So as an antenna gets smaller, the radiation resistance gets smaller faster. Therefore, if you make an antenna smaller, the radiation resistance gets smaller faster. The efficiency of an antenna goes down as it gets smaller. This is why we need big loading coils in small antennas. For example, if you've got a big antenna, like a big beam here on the left, you don't worry much about efficiency. That big antenna is an efficient antenna. But that screwdriver on that RV on the right is a low efficiency antenna. Any mobile whip antenna is a low efficiency antenna because it has very low radiation resistance. And if you put the turns too close together, you get lower efficiency. For example, you put them next to each other. This happens if you're in a loading coil, for example, if you put them too close together, because the skin effect moves the current not only to the outside, it moves it up to the upper surface. So in a loading coil, don't put the turns close together. It'll handle power, as it will. How does this antenna compare? I'm cutting through a lot of stuff rather rapidly for you here. But here is this particular antenna. The blue curve here on this radiation pattern shows you what this particular antenna that I've just showed you looks like. If you look at it from the top down, the blue antenna would be if it was a full-size 40-meter dipole. This is what its gain would be. It would be the blue curve. This is the one I'm showing you that we made with the cardboard loading coil that I'm showing you. This is the only amount of down it is. Very, very little. And yet this antenna is only 1/3 the size of the blue one. Tuning and matching. As you can see, this antenna is narrow in bandwidth. All small antennas. Any of you ever run mobile know that small antennas are narrow in bandwidth. You've got to constantly be tuning a mobile antenna, where you don't have to tune a big antenna. You can see this is what the blue one would, a full-size antenna would look like. It has a bandwidth of about 1.28 megahertz, whereas this one has a bandwidth of 18 kilohertz, narrow. But you can't do anything about it. It's basic physics. You need some way to tune this antenna. Well, the way I tune it is this way. I use a little jumper. Here. Actually, I should have moved the bolt down. That's why I put the red arrow here. I had the bolt attached. I was shorting turns originally. But later on, I realized somebody pointed out I shouldn't short turns. That's correct, you shouldn't short turns. I tune this antenna by just eliminating turns with a jumper made with a piece of a braid from a piece of coax. And here's how many turns you've got to skip if you want to tune it to different bands. And how do I hold this piece of braid onto aluminum or copper strip? With magnets. Works like a champ. Here's some neodymium magnets attached to one end of the braid, and some of them on the inside, and they stick like glue to the turns and make a great connection to the cardboard tube. And so, yes, I have to be able to get up into the attic if I want to change bands. But this is an inexpensive antenna. It isn't a motorized antenna where I can, at a push of a button, change bands. But it's a workable antenna. As a single frequency antenna, it works just fine. And here are the neodymium magnets. You can buy them from Amazon quite inexpensively. Remote tuning options. Now, some of you are going to say, well, I want to be able to remote tune this. Okay, there are ways you can remote tune this antenna. And if you want to get fancy with it, and I haven't gotten fancy with it, I'm quite happy to use it as a single band fixed frequency antenna. Let's say for PSK 31 or something like that. It's a great antenna for using up in the attic. But if you want to automate it, you certainly can. I'm not showing you this as a multi-purpose antenna for all frequencies, automatic button, push the button type antenna. But I think you can see if you want to make it that way, if you're enterprising enough, you can certainly do it. You can use a remote auto tuner, but you're going to have to put it up in the attic. Can't use it down in your shack. Don't try to tune this antenna up from down in your shack. It won't work. Warning, don't tune it in the shack. You'll waste all your power in the coax leading up to the antenna, because the SWR in your coax will be very high, and coax with high SWR hates SWR. All you'll do is heat the coax up. You won't get the power out. So this is a favorite antenna for hiding in antennas. So try a short loaded dipole. It works really very well. And here's my little dog Lolly. If you want to contact me, there are my websites and my email address. You can contact me anytime you like. I'm usually up and available any morning, Pacific Coast time, from about 7 o'clock onward, and be glad to answer your call or your email, or set up a Zoom meeting with you personally, and we can chat about antennas or other things. And that's it. I know that's quick, but that's what we like.
Got a few minutes for some questions?
Of course.
Go ahead, Joe.
How much power can that aluminum take?
How much power handling capability does it have?
Lots of power. Let me give you an illustration. how much power will a piece of 3/8 inch diameter aluminum tubing handle?
I would imagine legal limit.
A piece of 1 inch wide aluminum tape, 1.5 mil thick, will handle the same amount of power, because in both cases, the current is on the surface.
Well, wouldn't that produce so much heat that it would burn the cardboard?
No.
No?
No, because once you created a path for the eddies of current to flow off the conductor, then there's no heat in the tube. It's going into the air. That's the whole idea.
Yeah.
No reactance or no resistance in the tube, so it doesn't heat up.
Yeah. People think you're gonna burn up the foil and poof. No, it won't do that. I run all sorts of power in aluminum foil or copper foil.
One more.
One more question, go ahead.
Back 2-3 years ago, the hex beam was all the sensation. And now you don't hear of hex beam anymore. What's his opinion of the hex beam?
Somebody relay that question. I can't hear it.
Joe's curious, because a couple, 2-3 years ago, he heard a lot of information out there about the hex beam. And lately, he hasn't heard anything about it. That's probably because they work so well that nobody has any problems, so the squeaky wheel doesn't get the oil. They do work very well. I don't know what your opinion is of that.
Oh, the hex beam, I think the hex beam is an incredibly good antenna. In fact, I do a talk on the why am I having a brain lapse here, on the Moxon. The Moxon is just a hex beam, but with only 4 spreaders instead of 6.
Right.
And by using fiberglass spreaders and wire around the outside of the fiberglass spreaders, you can make beautiful multi-band beams. For example, the Moxon is a two-element Yankee, whereas the hex beam is also a 2-element Yankee, but the beam is more circular, so forth. They're excellent antennas, and very easy to build and very rugged. In fact, I gave a talk on the Moxon to the radio club that meets in the Pentagon Amateur Radio Club. I've given several talks to them, and when I gave the talk on the Moxon, one of the members showed me a picture of his hex beam that had come down in one of the big ice storms that had hit the East Coast about that time. And it was the hex beam all crumpled up in a bundle covered up with ice. And I said, "Oh, you poor soul, that's horrible." He says, "No. As soon as it melted on, we just went out there and popped it back up, and it went right up into place again." He says the hex beam is an incredibly durable beam. Yes, it may come down in an ice storm, but it'll go right back up again. That's the nice thing about the hex beam. So I highly recommend the hex beam, and it's a good place to get. It's the company that sells it, Max Gain Systems, or DX Engineering is the same company, the father of the same guy that runs Max Gain that sells hex beams. They sell that fiberglass tubing, great material for making antennas out of.
I got a question.
Sure.
Instead of coupling that antenna with reactance in the center of the tube, can you literally open that coil up and feed it in the middle, one way, one the other way?
Sure, why not?
Okay.
I mean, I just like that method because it's variable.
Right,
You know,
I understand. I just wanted to make sure that wasn't an issue. Because you're
Virtually no issue whatsoever.
Right.
It's just like you can center feed a dipole that has loading coils on both sides. You can center feed that one. It's just that it's going to be a little more difficult to find the match. You're going to have to be cut and hack a bit. That one, I just put that magnetic coupling transformer loop in there,
Right.
and it just tuned up so easy. But that's how I couple magnetic loops very often.
I wonder if you could off-center feed that and actually make an off-center fed dipole out of that system.
Oh, of course you could. You can easily make an off-center fed dipole that way. That loading coil has a great many uses.
That's the point I was trying to make to these fellas out here, so. It looks like it's gonna be a fun deal.
I only offered that one as an example. It's hardly, the talk wasn't on that particular one. The talk was on the concept of using that kind of constructional method.
And it was an excellent one too.
Good.
So,
Okay, I've got lots of other talks. Have me back. The one that's going most popularly now is the one on the magnetic loop.
yeah. Joe might wanna set that up with you at one point.
Sure.
If that, I'm interested in the magnetic loop, you know, there's a lot of stuff you can do with a magnetic loop antenna. I did an experiment with one of those back before AES closed. I built a small magnetic loop out of a couple of 2x4s and a tuning capacitor and brought
Sure.
it to that AES Superfest, and I tuned in all the crap, just with that little bitty antenna sitting up on top of the radios. I brought a bunch of Collins equipment down there.
They're quite amazing, but they're not very well understood by most hams, and so most of the articles you see on the internet are guess and golly designs that are very inefficient, very poorly optimized. So what I talk on is how to optimize the loop, because there really are six things you have to do, where the typical antenna, you don't have to do nearly so much to optimize it, but the mag loop to get a satisfactory one needs to have several things done to it to get it right. But when you get it right, it's a great little antenna.
Well, yeah, the best thing about them is you can use them for beverage, and you can cut out all the crap when you're trying to talk to somebody when you've got a mass amount of stations on the air.
Oh, you bet they have a wonderful null for nulling out interference.
Yep. Any other
Lots of-
questions? I think you've emptied us all out, and that was a great presentation, by the way.
Yes.
Okay, guys, well, have me back anytime. By the way, somebody's wondering, where did your town, Fond du Lac, come from? I know what du Lac means, but where does the Fond, what does it mean?
Bottom of the lake.
It's the first on the lake in French. That's where when the French were putting the railroad together up here, that was just the name this is the first town along the lake.
Fond, the foundation, what's the word in French for fond? What does the fond in French mean?
Foot of the lake.
It means
Foot of the lake, the foundation of the lake, I guess.
Right.
Something, okay, very good. I only know a very little French. I know a lot more German. I should live in Michigan. Okay, guys, we'll see you all later.
Thank you, and have a wonderful